Information codes, a general description, and then variable length binary codes, Huffman coding. Encoder channel decoder system. First block, source encoder. Source messages using code alphabet are encoded and information code words are achieved. For the fixed length code, all words have the same length. For the variable length code, at least two code words have a different length, and we will discuss such an issue during this presentation. This is the next block. Next blocks, channel encoder, channel and channel decoder, they will be discussed in the next screencast. Output of channel encoder, code words. Then at the output of channel we have output sequences, and then after channel decoder we have a decoder decision. This will be discussed later on during the next presentation. Now classification of codes. At first, information codes at the left. We will be dealing with the prefix condition codes. A prefix condition code is code if no code word is a prefix of another code word. This is a condition for prefix condition code, and we will be dealing with variable length code. We will skip fixed length codes, simple binary, gray, BCD, and hexadecimal. Optimum Huffman coding is the subject of next slides. First definition: the average code word length is equal to the sum of the code word lengths times the probability of the source messages. This is average code word length. The following theorem can be formulated. If the length of the ith word has these boundaries, then the average code word length is between the absolute minimum, it is the lower boundary, and the upper boundary is absolute minimum plus 1. What it means that by proper selection of code word length, the minimum distance of 1 bit from absolute minimum, which for binary code is just entropy of the source, can be achieved. By proper selection, we mean the most probable message or messages are encoded in the shortest words, and the least likely in the longest words. The distance from the absolute minimum, from this minimum, can be further reduced by encoding sequences of source messages, by encoding elf extension of the source, and this subject will be discussed later on. Now, Huffman coding. We have the following problem. We have a source of a given probability assignment. For this example, we have 5 messages, and these are the probabilities. And our task is to find the optimum code. And Huffman coding guarantees the optimum binary variable length code. This coding consists of 2 phases. Phase 1. Source is reduced to the binary source by joining the 2 least likely messages. For the original source, these are messages x4 and 5, and we join them to obtain the reduced source. The joined message now is here, and stage 2, we reduce our source to a source of 3 messages. The final stage, the source is reduced to the binary source, and this is the first phase. In the second phase, we encode, starting from the binary source, 0 and 1, encode a binary source. Then this 0 is prefix of code words obtained from this word x1 to x1 and x2 and so on. 10 is prefix of these 2 code words. That way the original source has been encoded, and the code is optimum what regards the absolute code length, code word length. For this exemplary data, this is 225 bit. The absolute minimum is 223, which means that the distance from the absolute minimum is very narrow, 002 bit. As I've said before, distance from the absolute minimum of the average length of a code word can be further reduced by encoding of sequences of source messages, simply encoding elf extension of the source. This is the formula, which means that, for example, for L equal 2, for the second extension of the source, the distance from the absolute minimum can be reduced to 0.5 bit. Next presentation, block codes and basic concepts and definitions.